Good day to everyone. I am very pleased to be given the opportunity to present in this very prestigious conference in spite of our absence. I am Editha Dinimalan and my field of specialization is on natural language processing. I will be presenting to you our paper entitled Open Source External Engine, a Resource and Parser for Spell Checker and Grammar Checker Add-in for OpenOffice Writer. This paper was taken from our research funded by the Department of Science and Technology, Philippine Council for Advanced Science and Technology Research and Development, or the AST-PICASTARD. The research was completed by me and my co-researcher, Mr. Davis D. Dimalan. After my presentation, Mr. Dimalan will present to you the prototype of our research. This is the outline of my presentation. After the abstract, I will present the architecture of our system, showing you the different components involved. I will also discuss the connection between OpenOffice Writer and an external open source DBMS, which is PostgreSQL. The details about the spell checker components will be discussed, as well as the algorithm. Then the grammar checker components will be presented and its algorithm. A discussion about the Tagalog stemmer will also be presented, as well as the suggestion strategy. In this research, we used a different approach in the development of a Tagalog spell checker and grammar checker add-in for OpenOffice Writer. We used a third-party open source software as resource and parser. This system can be used in both Linux and Windows OS. On the slide is the architecture of our system. Juno helped us access the different OpenOffice Writer objects and elements with ease. Examples of these objects and elements are the document, each word in the document and its position to the document, and etc. By using StarOffice Basic, one of the programming language supported by Juno, we were able to develop an add-in program for OpenOffice Writer that checks the spelling and grammar of a document written in the language Tagalog. The add-in is connected to an external DBMS, which is PostgreSQL, via Open Database Connectivity and StarOffice Database Connectivity. PostgreSQL serves as a resource or as a lexicon or lookup table, and at the same time as a parser through the use of stored procedures. The following are the spell checker components. On the OpenOffice Writer side is the spell checker GUI, which serves as the front end, and the external DBMS side, which serves as the back end, are the stored procedures composed of the lexicon lookup, Tagalog stemmer, and suggestion strategy. The input of our system is a document written in Tagalog. The algorithm for the spell checker starts with Step 1. Process current word from document. The current word is initially the first word. Step 2. If current word is found in the lexicon, then process next word from document. The current word is equal to the next word. In Step 3, do Step 2 until word is not found in the lexicon or until end of the document, which is, you have to repeat Step 2 until a misspelled word is found or until it reaches the end of the document. Step 3 is also the terminal step in the algorithm. In Step 4, if word being processed is not found in the lexicon, call stored procedure that will execute stemming. Step 5, look up resulting word to the lexicon after stemming is done. Step 6, if word is not found, do Step 4 to 5 again until word is found in lexicon or until stopping criterion is reached. In Step 7, after Step 6 and still no root word matches this resulting process word by stemming, roll back to the original input word. Continuing, In step 8, process the word by calling suggestion strategy stored procedure and send back suggested words to OpenOffice Writer. In step 9, display suggested words. User has the option to select which suggested word to replace the misspelled word or ignore to continue the next word. If not end of the document, go to step 2 and repeat the process. The following are the grammar checker components. The grammar checker GUI is found in the OpenOffice Writer side, and on the other hand, the external engine side contains the following components: the sentence tokenizer, direct lexicon lookup, Tagalog stemmer, part of speech tagger, and grammar rule analyzer. The grammar algorithm works as follows. In step 1, process current sentence from document, and then chop sentence into tokens or words by calling stored procedure tokenizer. In step 3, look up each tokens in the lexicon. If a token is not found in the lexicon, process the token using stored procedure stemmer until a root word is found. If no root word found from the token, then process next token. In step 5, all tokens found in the lexicon either by direct lookup or via the stemmer will be tagged with a corresponding part of speech. In step 6, extract the part of speech from the tokens, forming a string appropriate POS sequence for the input sentence. In step 7, process the string of POS using the grammar rule analyzer. The grammar rule analyzer will recursively look up to the rule table to check validity of grammar. Continuing, in step 8, if no valid rule is found for the input POS string, extract the rule closest to the input POS string and return suggested rule structure to grammar checker front end. In step 9, if no suggestion can be generated, prompt the user with the message, "No suggestion generated. Try to rephrase sentence." Then, process next sentence and go to step 1. If no more sentence to process, then terminate grammar checker. Okay. In this slide is the Tagalog stemming algorithm. We adopted TAGSA by Don Eric Bonos of 2003. TAGSA used to extract root words from an affix inflected word or words that were not found during direct lexicon lookup. The inflected word could also be inflected with prefix, infix, suffix, partial and full reduplication, or combination of any of the above inflections. With TAGSA, only Tagalog root words has to be stored in the lexicon, saving space and at the same time capable of processing more words. The suggestion strategy that we use in our system is the metaphone algorithm. The soundex function converted the misspelled word to its sounds-like equivalent. The soundex function that we used was intended for English words. Therefore, we recommend the development of a soundex function suitable for Tagalog language to be able to have a more efficient suggestion strategy. These are our references. Thank you.